Welcome to Ask and Learn.
We are given a deterministic finite-state automaton, and we are asked to find the language recognized by this automaton. The graph for the deterministic finite-state automaton is in exercise 17. You can use that as reference. So we see, looking at the graph, that it contains three states: S0, S1, and S2. And we're going to construct a table with two columns. On the left side, we have the different states, S0, S1, and S2. And on the right side, we'll have the inputs, which could be, in this case, either 0 or 1. And if there's an arrow from a state Si to another state Sj with a label X, then we'll write down Sj in the row Si and in the column X of this table. So for example, we see that there is an arrow from S0 to S2 with a label of 0, and so we'll write down S2 in the row containing S0 and in the column 0. Likewise, we complete the table so that the rest of that column is S2, S2, and the rest of the next column is S1, S2, S2. Okay, and we see that S0 is marked as the start state. Now, we see that since S2 is circled twice, this means it's a final state, and therefore a string will be recognized by the deterministic finite-state automaton only if we end at state S2. Now, let's break this down into cases. Suppose the string starts with a 0. Then, according to our rules, we're going to move from state S0 to state S2. And we see that once you get at S2, we always remain at state S2. This is a problem because S2 is not a, well, S2 is the final state. Sorry. It's not a problem. So it follows that any string starting with a 0 is included in the recognized language. So I'll write this in set notation as the concatenation of the set containing 0 and the clean closure of the set containing 0 and 1 is a subset of the recognized language. Now, let's suppose that the string starts with a 1. Then, according to our rules, we're going to move from state S0 to S1. And we see that we only move from state S1 to the final state S2 if the string has a second bit. And then once we get to state S2, we'll always remain there. So it follows that any string starting with a 1 followed by at least one bit, which could be 0 or 1, is included in the recognized language. So to write this in set notation, we have that the concatenation of the set containing 1 and the set containing, in this case, 0 or 1, and the clean closure of the set containing 0 and 1, we have that this will be a subset of the recognized language. But we notice that this can also be written by applying the concatenation to the first two sets as the set containing the strings 1, 0, 1, 1, and the set 0, 1 star is a subset of the recognized language. So that's all the cases, and so it follows the language generated by the machine will be the union of all these sets. So we have that the generated language is going to be set 1, set 0, 1 star, Sorry, there should be a 0, set 0, 1 star, union with set 1, 0, 1, 1, set 0, 1 star. And we notice that in this case, this is the same as the set 0, 1, 0, 1, 1, 0, 1 star, and this is our answer.